what we're doing now, maybe even more. So we are going to start on topic. Your book calls it topics. We're going to start on topic 7, trigonometric functions. Chapter 7 is trigonometric functions. We're going to do some new things with trigonometric functions. Today and this week, we're going to concentrate on trigonometric functions with acute angles. So essentially the right triangle, trig, this week, sine, cosine, tangent, things you've heard before. We get that last year you were in geometry. You did this in geometry last year. You understand last year was kind of a goofy year. And even if you did this in algebra as well, but this would have been done in algebra when you kind of started being at home all the time. So it's not new, but depending on how concentrated you could be, it might be a little bit new. And then we're going to talk about what we call law of sine and law of cosine. We're going to talk about angles within a unit circle. So really, this is really two sections, I guess. It's not only topic 7, but it's also going to be topic 8. So there's kind of two parts to this. But there's only certain sections out of each of these topics that we're going to cover. This whole week is going to be all about section 7.1. And 7.1 is trigonometric functions and acute angles. Okay, so we're going to talk about essentially this right triangle trig. So new topic, if you didn't have so much fun with the last topic that we did, hopefully you can get a little bit of a restart here with things to go. So if you remember right triangles, so we've got this right triangle here. Remember that right triangles are made up of, three sides, obviously. They've got three sides, but they have two parts. They've got legs. The two legs make up the right angle. So this angle down here, this little box right here, that means that the measure of that angle is 90 degrees. That's our right angle. The two legs make up that right angle. And the third side, it's called the hypotenuse. Now, couple things with the hypotenuse. The hypotenuse is always going to be the side that's across from the 90-degree angle. So it's the side furthest away from that 90-degree angle. This hypotenuse is always also going to be your longest side. It has to be. Okay? So it's the longest side, and it's across from the 90-degree angle. Now, if you remember the Pythagorean Theorem, Pythagorean Theorem helped you find missing sides of a right triangle. And we're going to use this a little bit, but the Pythagorean Theorem essentially says that a leg squared plus a leg squared has to equal the hypotenuse squared. And it's leg squared plus leg squared equals hypotenuse squared. That's not how you hear it. I mean, you always hear it a squared plus b squared equals c squared. That's what you're used to hearing. A squared plus b squared equals c squared. But understand, when we say a squared plus b squared, the a and the b values always represent the legs of our right triangle. The c value always represents the hypotenuse. So depending on what you're given, depends on which one you have to find or where you put it. And we'll talk more about using the Pythagorean Theorem here in just a little bit when we start getting into this a little bit, but kind of keep that in mind. A lot of times, in geometry, when they're talking about angles, you'll see this symbol. This symbol right here is called theta. That theta means that we want to find the measure of that angle, that particular angle. You'll hear find the sine of theta or find the sine ratio of theta. That means the ratio, that means that's the angle that we're looking for when you see those types of things. The other things that you'll see with the right triangle is a lot of times you'll see capital letters of A, B, and C. A vertex where two sides or two legs or the hypotenuse, they come together, those are always going to be represented by capital letters. I probably should have put the C there and the B there, but it's irrelevant, I guess. Doesn't matter which one you put where. But you'll always see those represented by uppercase letters. So today it may say find the measure of, or find the sine ratio of angle A. Well, A and theta are in the same place in this one. Find the sine ratio of angle C. So then we would find the sine ratio of this angle here instead. And we're going to talk about what those things mean here in just a little bit. Okay. So that's kind of the basic setup of any right triangle. You've got thetas, you've got legs, you've got hypotenuses, you've got those different types of things. When we're talking about trig ratios, we also have to talk about what we call the opposite side and the adjacent side. So we have to name the adjacent side and the opposite side. And when we're talking about adjacent sides and opposite sides, we're always talking about the legs. The hypotenuse is always going to be the hypotenuse. The opposite side and the adjacent side, those are going to change depending on what angle you're looking at. So let's say that we're looking at theta. And we're going to use that as our reference angle. We can identify the sides given theta. We know that this side right here is the hypotenuse. This leg over here can also be called the adjacent side. Now, how do I know that that's the adjacent side? What adjacent means is adjacent is the side that forms the acute angle that we're given with the hypotenuse. So the adjacent side is going to form the angle with the hypotenuse, the acute angle with the hypotenuse. That's what we're going to call the adjacent side. The other leg is called the opposite side. The opposite side is the leg that's across from our theta angle. So since our theta is here in this case, the side across from that angle is this leg down here. So we're going to call this the opposite side. The adjacent side makes up the acute angle with the hypotenuse. The opposite side makes up the side across from our acute angle. You have to be able to identify the opposite, adjacent, and hypotenuse. You've got to be able to identify those three sides on any right triangle in order to do anything we're going to do going forward. Because we're talking about ratios, a sine ratio, a cosine ratio, a tangent ratio. And these ratios are ratios of opposite over hypotenuse. So the first thing that we need to make sure that we can do is we need to make sure that given any right triangle, that you can label those different sides. So let's say here's our right angle. This is my theta. And I'll say that the lengths of this are 6, 8, and 10. The first thing we're going to do is we're going to identify the three sides as opposite, adjacent, and hypotenuse. And label them with O, H, and A. So the way I like to do these is I always like to identify the hypotenuse first. The hypotenuse is the longest one, and it's the one that's across from the 90-degree angle. So 10 is the longest one. It's across from the 90-degree angle. So I'm going to label that with an H. That's the hypotenuse. The next thing I like to do then is I like to say, okay, here's my theta angle. Here's the hypotenuse that goes with it. Here's the other one that goes with it. That must mean that this side is the adjacent side. So 6 in this case is the adjacent side because it makes up our given angle with the hypotenuse. That leaves the 8 then to be the length of the opposite side. So the first thing you've got to be able to do when we're talking about any trig ratio is we've got to be able to identify these three things. Hypotenuse, longest side across from the 90. Adjacent is the acute angle that's made up with the hypotenuse and your given angle, and the opposite is across from the theta. Now keep in mind that with any given triangle, if I said instead, find the opposite, adjacent, and hypotenuse for A, it can change. Now, in blue, this is the adjacent side to A, and this is the opposite side of A. The hypotenuse is never going to change, but the opposite and adjacent can change depending on what angle you're being asked to look at. If it's theta, 8 is the opposite and 6 is the adjacent. If it's angle A, 8 is the adjacent and 6 is the opposite. So the opposite and adjacent can change, the hypotenuse isn't going to. Okay, so let's take a look at this one. There's my right angle. Here's my theta. Let's go 3, 4, and 5. Go ahead and, according to theta, go ahead and label the opposite, adjacent, and hypotenuse. Just label them O, A, and H. Which one's the hypotenuse? 5. Which one's adjacent? And the opposite is 3. Good with that? Questions with that so far? All right, now that we can do that, then we can go into really what we call our 6 basic trig functions. So we've got 6 of them. You're going, what? We only have 3, sine, cosine, and tangent. Yeah, there are reciprocal trigonometric functions as well that we're going to talk about. So those are going to be new. So our 6 basic trig functions are sine. So our ratio, so all of these are going to have ratios that we put together. So we say the sine of theta. The sine of our theta ratio is going to be the length of the opposite side over the length of the hypotenuse. That's what our sine ratio is. So if we have our little triangle sitting over here, here's adjacent, here's hypotenuse, here's opposite. The sine ratio for theta is going to be the length of the opposite side over the hypotenuse. Now the whole goal of these ratios is to help us find the measure of this angle. So eventually, not today we're just going to set up the ratios. Eventually we're going to use this ratio to help us find the measure of that angle. Okay, so if I have a plane that's flying up in the sky and I know how high that plane is flying, and I know how far away it is, I can find this what we call angle of elevation by using one of these ratios. Not necessarily the sine ratio, but one of these ratios. So that's our sine ratio. The second ratio that you're somewhat familiar with is the cosine ratio. And the cosine ratio is the adjacent over the hypotenuse. That's the cosine ratio. And we just label it COS. So its ratio is adjacent over hypotenuse. The third one that you're familiar with is the tangent ratio. Tangent ratio is opposite over adjacent. A lot of times you'll hear us say sine is O over H, Cosine is A over H. Tangent is O over A. Or you'll hear us say SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. It's kind of a way to remember it with SOHCAHTOA. It's up there, it's over there. And it just simply says sine is the ratio of the opposite over the hypotenuse, cosine is the ratio of adjacent over hypotenuse, and tangent is opposite over adjacent. And those are the ones you're familiar with. Those are the three that you're familiar with. The ones that you're not so familiar with are the next three. And these are the reciprocal trigonometric functions. So the first one is the cosecant. Oops, let's try this again. The cosecant, which we label CSC. The cosecant of theta. Get rid of this. That is going to be the reciprocal of the sine ratio. So this is going to be the hypotenuse over the opposite, or H over O. Cosecant is the reciprocal of the sine ratio. Secant theta is our next one. The secant is the reciprocal of the cosine. So this is hypotenuse over adjacent, or H over A. And then the one to me that makes sense, tangent, the reciprocal function, is cotangent, the COT. And that's going to be adjacent over opposite, or A over O. So these are the reciprocal ones. The reciprocal for sine is cosecant. The reciprocal for cosine is secant. And the reciprocal for tangent is cotangent. This one usually doesn't cause issues. These do. How do I remember it? C goes with S. C goes with S. C goes with S. S doesn't go with S. C doesn't go with C. C goes with S. C goes with S. S goes with C. S goes with C. C goes with S. S goes with C. And that's how I keep them straight in my head. Okay. It's not SSCC. No. S goes with C and C goes with S when you're writing them. Okay. So the first thing then that we're going to do today and really tomorrow, because tomorrow really, I imagine some of you are probably going to be gone tomorrow. First thing we're really going to do is we're just going to write the different ratios for given triangles. So let's do an example. So we've got this right triangle. We'll say that the side has lengths of 20, 21, and 29. And we want to write the 6 trigonometric functions. Or the 6 trig ratios. So we want to write all 6 of them. Sine, cosine, tangent, cosecant, secant, cotangent. We just want to write the ratios for this angle given that theta is right there. Step 1, always label sides first. And this just helps you down the line. You don't have to look back and forth. Which one's the hypotenuse? 29 is the hypotenuse. Which one's adjacent? 20 is adjacent and 21 is opposite. Now I have them all listed. So now I can go through my ratios. Sine ratio. Sine is the length of the opposite side over the hypotenuse. Length of the opposite side is 21. Hypotenuse is 29. Now what I like to do, since I have to write all 6 of them, I'm just going to go ahead and write the cosecant ratio as well. Cosecant is hypotenuse over opposite. So 29 over 21. So I've got those two done. S goes with C. Now I go to the cosine ratio. Cosine A over H. Adjacent's length is 20. Hypotenuse is still 29. And that's all you have to do today. If it asks you to write it as a decimal, just do 20 divided by 29 in your calculator, hit enter.
You just need to find that.
Yeah, that's it. You're not going to find angle measures today or nothing. You're just writing the ratios today. Then I do the secant. Because all I have to do then is flip it. 29 over 20. And then the last one that we have is cotangent. No, we don't. We have tangent. Got ahead of myself. We have cotangent too, I guess. But let's do tangent first. Tangent, opposite over adjacent. Opposite is 21. Adjacent is 20. So that makes the cotangent of theta equal to 20 over 21. And that's all you have to do today. You don't have to change it to an angle measure. You don't have to do anything else with it. You're not going to find missing sides today. You're not going to find missing angles today. You're just getting used to writing the different angles today for the different triangles that you're given. Okay. So in this case, you were given everything. Yay. Well, what happens if you're not given everything? Okay, so in the next one, we've got this triangle, and we're going to say that this has length of 15, this has length of 8, and my theta's down here. But instead of finding them all this time, let's say that I just want to know the sine ratio of theta. Well, if we think about what sine is opposite over hypotenuse. And if I label what I have, what's my adjacent side? Which one's adjacent? What's 8? This is the adjacent. What's 15? Opposite. I don't know the length of the hypotenuse. But sine is equal to opposite over hypotenuse. So that means I have to find it. But it's a right triangle. So because it's a right triangle, I can use the Pythagorean Theorem to find the hypotenuse. So remember the Pythagorean Theorem, leg squared plus leg squared equals hypotenuse squared. So one of my legs is 8. My other leg is 15. So 8 squared plus 15 squared is going to equal my hypotenuse squared. 8 squared is 64. 15 squared is 225. Add those together, you get 289. And that's the hypotenuse squared. Take the square root. So that's 17. So my hypotenuse then is going to equal 17. It's the longest side. Make sure that's first. You can always kind of check it. 17 is bigger than 15 and 8. So at least I know it's the longest side like it's supposed to be. May have screwed up somewhere down the line, but at least it's the longest side. Now, opposite is 15. Hypotenuse is. You're done. There's nothing left to do. So in that example, you were given 2 of the sides and you had to find the third to help yourself write the ratio by using the Pythagorean Theorem. Another style of question that you may have is it may say, okay, what if I tell you that the sine ratio of theta is equal to 5 over 13? So I'm giving you the ratio of the sine theta, but let's say that I want to find the cotangent of theta. So this is what we're going to find, but I'm given the sine ratio. Well, if we think about cotangent, cotangent is the reciprocal of the tangent. So I need to know the length of the opposite side, and I need to know the length of the adjacent side. Sine is opposite over hypotenuse. So this means that 5 is the opposite side, 13 is the hypotenuse. Well, I need the adjacent. Okay, so I'm going to go ahead and draw this. I can put the right angle wherever I want. I can put the theta wherever I want. I'm going to put it right here. The side opposite of my theta has to be 5. So across from it, that has to be 5. So this length is 5. The hypotenuse, which is across from the 90, has to be 13. That means that I have to find this other leg down here. Not going to be 5. But we can use Pythagorean Theorem again, right? Right, because we've got a right triangle. So again, we can go leg squared plus leg squared equals hypotenuse squared. I know one of the legs is 5. So 5 squared plus the leg squared, because I don't know it, that's got to equal the hypotenuse, which is 13 squared. So since I didn't know one of the legs this time, I got to leave that leg squared as the piece that I have to find. I think so, yeah. So 25 plus leg squared equals, I think it's more than that. What is this? 169? It's more than 8. Is that right? 13 times 13, yes. Now what do I do? How do I solve it? Subtract 25. So leg squared equals 144. Now what? Square root of 144 is 12. So the length of this side is 12. So the length of that side is 12. So now my opposite is 5. My adjacent is 12. And that's your ratio. Pythagorean theorem is going to be used quite a lot over the next couple days to help you find missing sides. Okay? Eventually we're going to get away from having to use the Pythagorean theorem to find missing sides of right triangles. But the Pythagorean theorem is so nice. Just got to remember it. Leg squared plus leg squared equals hypotenuse squared. I'm going to have you try one more, and then we can get going on your assignment. So on your own, I want you to find the 6 trig ratios. That's angle A, that's angle C, that's angle B. Let's go with 12, 37, and 35. I want you to find the 6 trig ratios. So write the 6 trig ratios for angle A. Label first, label first, label first. We're going to spend quite a lot of time on this the next 2 days. If you can't label them, identify the opposite, adjacent, and hypotenuse, becomes a bit of a pain in the butt. How many are planning on going up tomorrow? Either in the band or on your own? Maybe? clearly a B.
It looks like an 8.
Clearly a B. I know somebody needs to learn how to write better, but he's not going to, so live with it. So there's my A. So 12 is the opposite. 37 is the hypotenuse. 35 is the adjacent. AO and H. So sine is opposite over hypotenuse, 12 over 37. Cosine adjacent over hypotenuse, 35 over 37. And with the sine and cosine, that ratio should always be less than 1. So if you divided them out to get the decimal, that should always be less than 1. Tangent doesn't matter. Tangent, opposite over adjacent, 12 over 35. Cosecant and secant, 37 over 12 and 35 over 12. Cosecant and secant, those ratios should always be bigger than 1 because your hypotenuse is on the top. It's always along the side. And then cotangent, 35 over 12. Okay. So there it is. So those are your 6 trigonometric ratios. Sine, cosine, tangent, cosecant, secant, cotangent. C goes with S, S goes with C. C goes with S, S goes with C. As far as your reciprocal functions. Make sure you use Pythagorean Theorem to find any missing sides that you have to do today. Leg squared plus leg squared equals hypotenuse squared.